In this video, I'm going to go over some Quiz 4 problems. Quiz 4 covers 2.5, 2.6, and 2.7. So the first question here is looking at a maximum and a minimum question. And here the two formulas are given to you. You're given that the sum of two numbers is going to add up to be 48. What is their maximum product? And on this, you're going to take the formula that you're given, the sum of the two numbers is 48. You're going to use this to be able to rewrite this function in terms of one variable, so in either isolate the x or isolate the y. In this case, if I isolate the y, I would have 48 minus x. I'm going to use this fact to plug it into my Q function that I want to maximize, and I'm going to then have a function in terms of only x, which allows me to then take the derivative of this function with respect to x, set that equal to 0, and solve for the values that would create a critical point. I would have to verify that that critical point is going to either be a maximum or minimum to then be able to apply that. So doing the calculus here, I can rewrite Q as 48x minus x squared. Then I take the derivative with respect to x, I would have 48 minus 2x. Set that equal to 0, I would have 2x equals 48. Divide through by 2, and I would have x as 24. So this gives me the critical point. To verify this critical point is going to then be a maximum, I could do the first derivative test, which if I look at the derivative of q with respect to x, and look at the point 24, on the left side of 24, if I plug a number that is less than 24 into the derivative, I end up with a positive value. So if I plug in x is 0, I end up with 48, which is positive. If I plug in a number greater than 24, if I was to plug in 25 here, I'd end up with a negative number. So that tells me on the left side of 24, my slope is positive, and on the right side of 24, my slope is negative. So that tells me that this point is a maximum. I could also use the second derivative test. Using the second derivative test, I would have second derivative is minus 2, which is less than 0, which tells me the function is concave down, which means that the critical point is also maximum. So verifying it's a maximum, I can use the formula that we calculated here to find y. Y is going to be 48 minus 24, so it turns out x and y are equal to each other. The maximum product would then be 24 times 24, which would give me 576. The next question is very similar, except that it has a little bit more application in economics, and we're coming up with this price per suit function. It's also, this x value is how many suits you're going to be producing, and the costs for producing those suits are given. Total revenue, the money you're making, is going to be the number of suits you sell times the price of the suits. The profit is going to be your revenue minus your cost. And you have to be very careful with this negative here. You're going to make sure you distribute it to all the terms in your cost function. And you can see here, if I take x times p, I end up with 170x minus 0.5 x squared. If I then take the profit function, I have the revenue, which was given as 170x minus 0.5 x squared, minus the cost. You want to be very careful that you end up distributing this negative to both terms. And you can see here the price. The calculus comes in when you take the derivative of p of x with respect to x, and you set that equal to 0. And doing so, you end up with x is 68. The maximum profit is going to be plugging x to be 68 back into the profit function. You don't want to plug it back into the derivative of the profit because that will be 0. And then the price per unit then is set by plugging this x value into this price function, P. So 170 minus 0.5 times 68, which would give us 170 minus 0.5 times 68, which would give us $136. So the suit would then be priced at $136. This next example, very similar. What is the current weekly profit? It looks like going through, it's pretty straightforward. Currently the company builds and sells 6 laptops weekly. You're given the profit function here. How much profit would be lost if the production sales dropped to 5 laptops per week? So you can do that calculation. The marginal profit when X is 6. To calculate the marginal profit, you're going to take P of 6 minus P prime of 6. So I know these numbers are a little tedious, so be very careful the way you plug them into your calculator. And then D, given the marginal profit here, using A and C, you're going to calculate the profit resulting from the production of 7 laptops is going to be approximately the selling 6 plus the marginal profit of when X is 6 to get to 7. So you're just going to add those two together. This problem is very similar to the first problem. You want to maximize this Q function given X and Y. So here you're going to rewrite this function that you're given in terms of only one variable. And here you could write y squared equals 9 minus x and plug that directly in for y squared here, since you know what y squared equals. And then so Q would end up being 4 times x times 9 minus x. So Q would be 4 times 9, which is 36. 36x minus 4x squared. Take the derivative with respect to x. Is 36 minus 8x. Set that equal to 0. 8x equals 36. So 36 divided by 8. So then x is 9 over 2. And if x is 9 over 2, we want to find y. We can plug 9 minus 9 over 2, which would give us 9 over 2. So y squared is 9 over 2. You take the square root of both sides. It says they are only positive numbers, so we can drop the plus or minus and know that we're just taking the positive. So we end up with the square root of 3 over 2. Or sorry, we end up with 3 over the square root of 2. We can rationalize the denominator and get 3 square root of 2 over 2. I believe you could probably put your answer in as the square root of 9 over 2, and it should accept that. So this is just a more acceptable answer, but I believe my math lab should accept any proper answer there, any correct answer. The next question here has to do with implicit differentiation, and the key for implicit differentiation is when you take the derivative with respect to x of a function of y, that is actually dy over dx. You have to be really careful when you're taking a function with respect to x of x and y, where y is a function of x. You have to use the product rule. So this would be this would be the derivative of the first function, hold the second one, plus the derivative of the second function, the dy over dx, hold the first function. And the whole point in this is to solve for dy over dx without actually getting y by itself. So looking at what's going on here, we have to be very careful what we're doing with this term, and this term, since they all involve a y. So going through and doing implicit differentiation here, the first term just has an x in it. That's going to just be 4x. Pretty straightforward. The second term has an x and a y, so we're going to have to do something like this, the product rule. So we have 4, the derivative of x is 1, hold y, plus 4x, because we're holding the first function, and then the derivative of y would be dy over dx. The third term, we have a y squared, so we have to use the chain rule. We'd have 10y to the first power times dy over dx. Then the next term, we would have 17 dy over dx. The derivative of a constant is 0, and the derivative of 0 is 0. So cleaning that up here, the terms that we want to isolate to one side are any terms with a dy over dx in them. We can move everything else to the other side, and so we'd have minus 4x minus 4y, minus 4x minus 4y. And then if we factor out the dy over dx, we're left with a 4x plus 10y plus 17 equals what we have over here. Solve for dy over dx. We have a minus 4x minus 4y in the numerator and a 4x plus 10y plus 17 in the denominator. And then I can evaluate that at the given point. X is minus 2, y is 0. And I plug that into what's given, and I should get 8 over 9. So you can verify some of that. Here it looks like they just factor out the minus in the numerator. And that's fine. You can leave it like this, or you can factor it. And then, so that's all that is on this specific quiz. If you have any other questions on any quiz that you've taken, any problem number, just let me know and I could make a video on that specific question. Hope this helps.